everybody. So here we go again. This is how existence works, okay? So if you know anything about particle physics, the fundamental building blocks of existence are the photon and the Higgs boson. Okay, to break that down, it's the photon and the boson. Okay, so if you want to look at it in a wave format, this is the photon. The photon is the first part of the wave. And the Higgs boson, or the boson, is the second part of the wave. Okay? So, the way that it works is you have the information spectrum, which a lot of people call the electromagnetic spectrum. I like to call it the information spectrum because that's what it is. Okay? So it starts at love waves, which oscillate at 10 to the 0. Okay? Then you can think of love waves as magnetic waves that are basically pushing out. Okay? And then you have radio waves, microwaves, infrared, light, ultraviolet, X-ray, gamma waves, and then at the very end you have entropy waves. Also known as gravity waves, which oscillate at 10 to infinity. Okay? That's the information spectrum. Okay? But the thing about it is, love and entropy go all the way up and down the spectrum. Okay? So you can think about it like this, okay? You have basically love waves, which are the very origin of the spectrum, okay? And then you have all the other levels of the spectrum. See it? Okay. Radio, micro, infrared, light, ultraviolet, X-ray, gamma. Okay, so, and on the outside of the spectrum, you have basically entropy, also known as gravity. Okay, so you have radio, microwave, infrared, light, ultraviolet, X-ray, gamma, and it goes back in to love and magnetic, okay? So they're going both directions because they're interchangeable, okay? Because 10 to the 0 equals 1, okay? But if you think about it like this, 0 is basically the same thing as infinity, because if you get a sphere like 0 and you move it every which direction, it becomes infinity. They're both the same thing. Okay? So, love waves can be thought of as either photons or Higgs bosons. Okay? They can both be basically used interchangeably. Okay? So you can think of this in the very middle as love or magnetic pushing out, and this as entropy or gravity pulling in. Or you can think of this as the photon pushing out, and this as the boson pulling in. Okay? They can be kind of like more or less used interchangeably. Okay? So, that explains that. So, all you're basically seeing within existence is infinite birth and death of both photons and bosons. Okay? Because you have, okay, these are the building blocks. You have photons, Higgs bosons. Okay, so what exactly are Higgs bosons and photons? Well, Higgs bosons are also W negative bosons. Photons are W positive bosons. Okay? And what is the horizon of the photon or Higgs boson? Well, it is basically where, think of this as space surrounding the sun. Okay? So, relative to the sun, the largest boson is basically the Higgs boson. Okay? So, relative to the sun, the Higgs boson gets smaller and smaller and smaller and smaller until, relative to the sun, the horizon of the sun, the boson, the Higgs boson, is as small as it can be. Okay? And the photon is as large as it can be. Okay? Because I'll get into that in a minute, but the sun is basically just a photon. Okay? But once it gets to the horizon of the sun, the Higgs bosons are as small as they can be relative to the sun. The photons are as large as they can be relative to the sun. Okay? Now, after it hits the horizon of the sun, the photons begin to get smaller and the Higgs bosons begin to get larger. Okay? So, in the middle of the sun, the photon, is space. Okay? Because all the Higgs boson is space. The photon is light. Okay? So, the Z bosons are the horizon. Okay? They're basically what separate the photon and the Higgs bosons. Okay? So we've explained what photons are, what Higgs bosons are, what W positive bosons are, what W negative bosons are, what Z bosons are. Okay? Those are basically the fundamental building blocks of existence. Okay? So, W positive bosons are basically photons. W negative bosons are basically Higgs bosons. Okay? So, out of photons, string is basically infinitely expanding. Okay? In every which direction. Okay? In Higgs boson, string is infinitely contracting, okay, in every which direction, okay? In a photon, time basically moves forward. You can think of it as positive infinity. In a Higgs boson, time basically moves backwards. Think of it as negative infinity, okay? Which are the same thing as the sphere. Okay? So, for instance, that's why whenever astronauts are out in space, relative to them, relative to us, time is moving slower out in space because there's more Higgs bosons out in space than there are photons. Down here at the surface of the Earth, there's a lot more photons relative to Higgs bosons. So it's basically an equilibrium, okay? But if you get to a place where there's a lot more Higgs bosons, time will move backward, okay? So, let me explain to you how it works relative to a galaxy. Okay, so in the middle of a galaxy you have basically a black hole. And then on the outside of the galaxy, you have stars. I mean, not on the outside of the galaxy, but on the outside of the black hole, you have stars being orbited by planets, moons, and asteroids. Okay? So, the way that it works is out here, so this is all basically space, okay? But a black hole is a high concentration of space, okay? So, consider it like this, okay? So everything outside of this sphere is dark energy feeding in, okay? So it feeds in to the photons, which are stars, which basically the dark energy from it feeds into the photons, okay? And the photons thereby push out more strength, okay? Infinitely expand, okay? And those basically charge the gluons, okay? Which gluons are the same thing as neutrons, which are the same thing as planet, moons, and asteroids, okay? So it charges the photons, which thereby charge the gluons, and the energy keeps moving in towards the black hole, which is a high concentration of space, okay? All this within here is space as well, but this is a higher concentration of space, okay? Where there gets to be such a high concentration of space that time begins to move backward, okay? So the closer you get to the black hole, the more larger the stars are, okay? And the space within the stars are larger. So out here, you have stars that are relatively small. With their own little solar systems around them. Okay? So it's basically just spheres getting infinitely larger as they move towards the center of the galaxy. Okay? So the photons are getting larger and the Higgs bosons are getting smaller. Okay? But what happens if we get on a spacecraft and we leave the Earth and we travel to the black hole? Well, the thing about a black hole is you're never going to catch it, okay? It's just like chasing a rainbow. You're never going to catch it, okay? But what you're going to see whenever you get to the location where mathematically you thought that the black hole would begin, what's going to happen? Well, you're going to start seeing stars get smaller again. And you're just going to keep seeing more space, more planets, moons, asteroids, more stars. But the thing about it is, you're going to start seeing stars getting younger and younger and younger, getting smaller and smaller and smaller. Okay? Because you're going to be going back in time. Okay? You understand that? So, let's talk about how this relates to you. Okay? So, say you take an apple, okay, and you eat an apple. Well, think about it as a series of spheres, okay? So the spheres within the apple are relatively large, okay? Then your field of energy absorbs them, and the spheres get smaller and smaller and smaller until they go into your digestive system, and they get broken down, broken down, broken down, broken down, until they get broken down to the point where they're just photons and Higgs bosons. Okay? And then what happens to them? Well, they start feeding the dark energy, because that's basically just what dark energy is what's within you. Okay? So that gets broken down into the fundamental photons and Higgs bosons, which are what? This is where it begins, okay? And it starts to happen again. Do you understand that? All the photons and Higgs bosons are within you. Okay? They get broken down into Higgs bosons and photons. And the photons start to get larger and larger and larger. Higgs bosons get smaller and smaller and smaller until what? They reach the black hole where time begins to reverse again. Okay? All right. So that's how to explain that. So let me get back into what photons are exactly, okay? So photons are protons. Protons are stars. Higgs bosons are electrons. Electrons are space. Space is basically a black hole. But a black hole is just a high concentration of space, which is a high concentration of electrons, which is a high concentration of Higgs bosons. Okay? So infinite photons and infinite Higgs bosons, what do they make up? They make up gluons. Which what are gluons? Gluons are neutrons and planets, moons, and asteroids. So what does this mean? If photons are protons and stars, Higgs bosons are electrons, space, and a black hole, gluons are neutrons, planets, moons, and asteroids, what does that mean? That means that you are the universe, literally. You understand that? So, that's basically how it works. Because the Earth is a gluon, which you are on. Okay? So you have the Earth, which is a gluon, which you are on. And then you have the Sun, which is a photon. And then you have space, which are Higgs bosons. Okay? So you are literally the fundamental particle as well as the universal particle. You understand that? So all you can see out there, if you want to watch my videos talking about basically quarks and leptons and all those things like that, you can. My last two videos pretty much cover that. But all we can see out there is within one hydrogen atom. Okay? All we can see, all the galaxies, all the stars, all the planets, moons, asteroids in space, all they are is photons, Higgs bosons, and gluons. That's all they are. All we can see, all that's out there, is within one hydrogen atom. All the galaxies that you see are all the elementary particles within one hydrogen atom. It's a beautiful thing. It's a very beautiful thing. And everything is so infinite. It's so infinite. All that you're seeing right now is basically the death and birth of photons and Higgs bosons. That's all that you're seeing. That's all that you're seeing. And most of the stuff that's going on, that's on the information spectrum, is invisible to you. You can't even see it. That's why whenever you look out in space, for the most part, you just see clear, which it goes so far out that it appears as black, but it's not really black. It's just clear, okay? This space that's within this room is just as infinite as that space that's out there. It's the same thing. It's just down here, we're looking at things at the highest degree of infinity, okay? Up there, we're looking at the lower degrees of infinity, okay? But it's all infinite. All that you're seeing, everything, it's completely infinite. So yeah, that's pretty much it. That's all it is. It's an infinite series of spheres, getting infinitely larger, infinitely smaller, infinitely expanding, infinitely contracting. That's all that's happening. That's all that it is. That's all that everything is. It's perfect. It's beautiful. So if you have any questions, you can write it in the comments. Like I said though, it's basically just Higgs bosons, photons, Higgs bosons, photons, Higgs bosons, infinitely expanding and infinitely contracting. Every which direction, infinitely. It's beautiful. So, that's pretty much it. That's existence. That's how it works, okay? And I know there's a lot more to existence than that, but it's how it works. Basically just positive energy infinitely expanding, negative energy infinitely contracting, every which direction. It's a beautiful thing. So that's pretty much it. That's the lesson for the day. And that is existence in a nutshell. So just understand that whenever you're looking at something, you're looking at this wall, you're literally watching infinite photons expanding, infinite bosons contracting, basically birth and death. You're watching birth and death on an infinite level, going every which direction. That's how infinite it is, okay? So I'll explain relativity really quick one more time. Even the speed of light, if you account for both particles and waves, it's infinite, okay? Everything is infinite, okay? So relativity-wise, Okay, if I put my hand closer to you, well, relative to you, my photons are larger. My Higgs bosons are smaller. I take my hand away relative to you, my hand is farther away, so my photons are smaller. My Higgs bosons are larger. Okay? It's that simple. That's how it all works. That's how everything works. Okay? It's a beautiful thing. So, yeah, that's pretty much it. If you want to contribute to my GoFundMe page, it's Magnitis Toys, Magnitis Toys. If not, that's fine. I just appreciate your time watching this video, and just go out there and be kind to one another and enjoy it. All right? Thank you.